Alright, so welcome back to this next video. This time we'll discuss the effect of the layers architecture. I have prepared a few layer set. The first one is a network with only 200 neurons as its hidden layer. The second one has two 200 neurons hidden layer, and the third one has three 200 neurons hidden layer. As we will see, this tree architecture will estimate the function well, but they will have too many neurons. The fourth configuration has three hidden layers with 150 and 20 neurons in each layer respectively. Finally, the last example has 5 layers with 10 neurons in each hidden layer. All these configurations will estimate the function reasonably good, but they are definitely not the same. So let's run the code to see how they will perform. Okay, so as you can see here, the performance is roughly the same in all of the 5 networks. So the question now is which one is better than the other? From an accuracy point of view, they are roughly the same, but there are other considerations to take into account. Let's first consider the first 3 networks. The first one is smaller than the other 2. Thus, given their performance is roughly the same, the first one is definitely better as the two latter ones has more capacity, and given the small training data that we have here, they are more likely to overfit the data, meaning the network will memorize the data set instead of generalizing over it. In practice, though, it is safer to start with a network that overfits and then modify it to generalize. And there are different schemes on how to do that we'll get in later videos. The rationale behind that is that if a network can overfit, it means that there is most likely a way to make it generalize. Whereas if the network underfits, you can't tell whether it's because the problem is unsolvable or your network doesn't have the capacity or any other reason. So from the first 3, the first network is better. Now let's compare it to the last 2. The number of neurons is smaller in both of them than in the first one. The last network is deeper than all of them, and that's just one thing you have to know about neural networks, which makes them very different than other machine learning methods, is that they extract their features from the training data. With more layers, this feature can be built upon and create a complex features set that eventually will lead to better classification or regression in our case. So with that rationale, the last model with less connection between layers but with deeper architecture seems to be a better choice. In the next videos, I will go over the hyperparameters, how to tune them, and how they affect the training process. So if you want to follow on, please consider subscribing to the channel and hit the notification bell to be notified. Also, feel free to ask questions in the comment section. I will try to answer them as soon as possible. Thank you for watching, and see you soon.